percent, if you don't learn anything else from me, percent will help you when you take the SAT, the ACT, the GRE. I just took that. I know all about that. But it was kind of cool because all I had to do was remember my own teaching. But they'll tell me your gum's total mass.
Before it was 8.43.
Okay, do not write down this part. You're about to do your own gum. So percent is defined as percent is equal to part divided by whole. Write this part down. Sorry. Times 100. So I need the whole mass of her gum. So what would you say the mass was?
8.43.
Okay. And then I'm trying to figure out the percent of sugar in her gum. So what was your aftermath mass?
2.45.
So 2.45. So her percent sugar, I'd actually have to take and subtract, right? Your after mass, you have to kind of work backwards. So what you started with, 8.43 minus, and she said 2.45 was left. So basically, and this is kind of cool, on the nutrition information, it says how many grams of sugar? It says 6. And it's 5.98. Isn't that interesting? That's cool, you guys. So the part that was sugar is basically, I mean, you can eyeball this. This is about, probably about 70%, 72%, I don't know. But I'm going to take part, so 5.98, you can do your own now, 8.43 divide at 70.93% sugar. So you take the part, I spelled sugar wrong. You take the part that's sugar and you divide it. That was part that was lost. It dissolved in your mouth. It went really quickly. That's why it tasted yucky afterwards. Sugar. So having said that, can we also calculate the part that was gum? Yeah. So her mass that was gum. What did you say your mass? 2.45. So I'm going to do part gum over the whole thing. Now, this have to add up to what? What do percentages have to add up to? Yeah, so I can eyeball this and I can tell you this is going to be 29.07%. But it would be better if I was taking a test to go ahead and work it out twice and then check my answer. So it is 29.0, it ends up being 06. I know it doesn't add up perfectly, but I round it. And that's gum. So I'm going to give you guys about 2 minutes to do this for your own gum. And I need your materials, people, to walk back there to get you a book. A book. Each person gets a book. I don't know if we're going to get to it, but we might.
That's sugar, but yeah, I guess so. The whole, the initial, after.
Yeah, so the part that was left in your mouth that didn't taste so great, that's the part that's gum, because the sugar dissolved and it went away. So we got to subtract to get it. Your percentages should add up to about 100. Yes, ma'am. That was her number. Your numbers are different. 5.98, I took her gum and I took away, so I took her after. I took her before and I minus her after. So take your bigger number and subtract your smaller number. The part that was left. Yeah. As long as your percentage is up to 100. Did you guys have percentages that add to 100? Yeah. Okay. Did anybody else get 6 grams of sugar on the dot? I picked the right person. That was pretty awesome. So do you understand how to do percentages? You good? Y'all are still doing math? I gotta move on with my life. Let's go. We don't have a whole lot of time. Yes. That's what this So you're going to get 5.99 for them. I mean, sugar. Okay, moving on. I know some people are still writing. I know. I'm making stuff up, you know. It's true meaningless. Chemistry's a lot of fun. Okay. Whoops. Alright, I know some people are finishing up, that's why I'm not talking. At least I got a little chicken. Can we write this down? Yeah, you can go ahead and write it down if you're ready. I can't write today. I got it. Okay, so what's about to happen, the reason I gave you a piece of gum, is because you can calculate the percent composition of sugar and gum by taking the part and divided by the whole mass. The part of the mass divided by the whole mass. So what's going to happen now is you're going to be given compounds. And this is like the first step. Like our knowledge of going to moles and our knowledge of doing percentages are about to come together, and you'll be able to figure out these formulas that we're going to. Anyway, can you figure out the molar mass of magnesium phosphate? Can you do that? Yes. Who said no? Everybody said yes. All right, so go ahead and find the mass of magnesium phosphate. Reminder, that's 3 magnesiums, 2 phosphoruses, and 8 oxygens, right? You can see after you mess that up, everything's going to be messed up because that's the bottom number. So to do that on your own, I'm going to be doing it on the board. We'll chat when we're done. Do you see how I'm stacking these on top of each other? I would highly recommend you do that. If you're just thinking your calculator, well, that's okay too, but you're about to have to show some work, so. Okay, and then I'm going to add them all up, right? Oh, there's 8 oxygens. I said that and then I wrote it down wrong. Just kidding. So that'd be 128. My bad. I'll write it in red since I was wrong. Did you get 262? Yeah. 0.87. So, let me ask you a question. Is this the part or the whole? That's the whole. And so it actually behooves you, helps you to show your work on these, because when you do the percent composition, you're about to have to run out this fraction, and this fraction, and this fraction. So I have it all nice and neat, so when I go to work it out, check it out. Whee! I'm going to go 72.93. That's the part, that's magnesium, right? Over 262.87. That makes sense. Okay, and then I'm going to times by 100 and get my answer. Times 100 equals. Okay, and then I'll have 61.94 grams of phosphorus divided by 262.87. My pen's getting a little lazy with me. I can't help it. Times 100 equals. And then 128 grams. Come on, pen. It's lagging behind. I gotta start a new program. 262.87 grams. And all these added up should give me 100. So, anyway, go ahead. Give it a try. 72.93 divided by 262.87. So this is 27.74%. And that's of magnesium. Then 23.56%, and then that will be for phosphorus. .69%, and that will be for the oxygen. And if you add these numbers up, you'll get 100. And when you take your tests and quizzes, you should do that with your work, and then you'll know you did it right. Now, honestly, does this seem that bad? It's pretty chill. Yes, ma'am. 72.92? Oh, yeah, it doesn't matter. As long as you're close. I mean, and when you add it up, if you get 99.98, that's cool. No worries. You gotta just be close, okay? Fine. Pew pew. Okay. Yes, ma'am? Any questions? You wanna try one? Well, you're going to, so it's fine. So, determine the percent composition of glucose. Give it a try all by yourself. So C6H12O6, get that down and then look away, do your own work, and I'll be working it on the board. We can talk about it. Is your molar mass 180.18? Get a ticket if you want one. Sorry, my pen is not writing well. And this is what it is. I have to restart it. do you guys need to see another one of these, or do you get it? It's pretty straightforward, right? We'll do some on the warm-ups and stuff, but this is like the easiest thing ever. I actually have an example from the book. I can't make empirical formula ones up because they have to come out perfectly. So have you ever seen me like actually look at something? It's the first time ever. No, take a picture. Okay. I see people still writing. So these percent compositions are found like in labs. So when you get into AP chemistry, they have a thing called like a mass spectrometer, I think it's called. And anyway, they basically can see the mass of particles and they get the different percentages. And then if you've ever watched like a crime show and they can tell you what something's made out of when they put the sample in the machine, they're using percent compositions to do that. And so sometimes you have to find the percent composition, and sometimes you're given the percent composition and you have to determine the formula. So we're mathematically basically going to do what some of those computers do to figure out like what substance is found in the lipstick or in the tire track or whatever. Kind of fun, right? It's not hard. It has a poem. Okay, I gotta give you a poem now. Do you have this down? No, I'm serious. Like, do you trust me at this point? Okay, if you don't like the poem, then that's fine. So here we go. It's percent to mass. Oh, here, let me help you out. For empirical formulas. I spell empirical formula wrong. I did. It's an I right there. JK. For empirical formulas. I do it every time. There are 4 steps. Percent to mass. There's Jordan. Mass to mole. Divide by small. Tomorrow on the do-now, I'm going to go ahead and tell you that you're going to have to write this down 5 times. And then I'm not sorry. Okay? So, divide by small. Multiply to whole. And Jordan. Multiply to whole. Percent to mass, mass to mole. Divide by small, multiply to whole. I'm going to keep saying it till you're done writing. So write it fast. Percent to mass, mass to mole, divide by small, multiply to whole. Percent to mass, mass to mole, divide by small, multiply to whole. Oh, we're still writing. Percent to mass, mass to mole, divide by small, multiply to whole. One more time for the people in the back. Percent to mass, mass to mole, divide by small, multiply to whole. Okay, all together. Percent to mass, mass to mole, divide by small, multiply to whole. Why am I the only one dancing? Okay, so here we go. I did green, red, purple, black. I'm going to use 4 different colors. So green, red, purple, black. Okay, so here's what the problem looks like. So it'll say something like, it'll say in an experiment or in an analysis, a sample was found to be 48.64% carbon. Should write this down. 8.16% hydrogen and 43.20% oxygen. And then I'll say find, I'm going to abbreviate, empirical formula. Oh, I need to add one more thing. It's molar mass. Can I didn't give me this. Oh, that's really unfortunate. Can I act like I didn't do that part? We'll do that next. Find its empirical formula. So find empirical formula. Ready? This is really hard, but there's 4 steps. Percent to mass. This is the hardest thing we've ever done. Ready? If it's a percentage there, all you're going to do is you're going to change the percent sign to a gram sign. Yeah. Now, if they give it to you in grams, you don't have to do that. Okay, so I'm going to take, you don't have to do what I'm telling you, but you should. I'm going to take, and you know how I did the percentages, I stacked them on top of each other? You're going to stack them on top of each other. So here's step 1. I'm going to use 4 different colors. Percent to mass, 4.64 grams carbon over 1. We're basically about to convert these to moles, each of them, because it's percent to mass, mass to mole, right? Stack it on top of each other. Nice and clean, units and element. I'm telling you, this will make it break you. Okay, 8.16 grams hydrogen. I am so southern. 43.20 gram. Oh, I forgot that other part. Just kidding. Whee. Okay. That is 6. Okay. And then the last one was 43.20 grams oxygen over 1. I've done nothing except for put it over 1. I'm stacking them on top of each other, okay? And I wrote down grams instead of percent. Have I lost anybody yet? That's the first part, percent to mass. What is the next part? Mass to mole. How do I go from mass to mole? How many steps is that? Okay, see how I had to teach you that first? So this is the second step. So this is step number 2 right here. Coming at you. I'm just going to do all 3 at the same time. These are different fractions, different things, but I'm just going to go ahead. So percent to mass, mass to mole. So where do I get information for grams? So there are 12.01 grams of carbon in 1 mole of carbon. Write down the element. Then here, there's 1.01 grams of hydrogen and 1 mole of hydrogen. Complete the oxygen fraction on your own. Let me say it again. Complete the oxygen fraction on your own. Oh, it's just 16.0. Alright, can you work these out? I hope so, because that's what we've been doing, right? So go ahead and get dividing. Go ahead and work them out, and then write down moles carbon, moles hydrogen, moles oxygen. Oops, I forgot to divide. Oh, oops, wrong unit. Hope you're not copying me. G down there, and then I did what we've been doing for 3 days. All right, cool. So, divide by small. Which one of these numbers is the smallest? 2.7. Right. So, let me do a different color. I don't remember what color I was doing next. But I'm going to divide all of these by 2.7. Go ahead. This one's going to be 1 mole of oxygen. And again, we're trying to figure out a formula. So we're trying to figure out, like, the written out, what is the stuff made of? Is it CH3? Is it CHO4? What is it? So these are telling us the ratios. Now, at this step, this is the only time in chemistry I'm ever going to tell you to round. So, stop what you're doing. Look up here. When you do this middle one, you're about to find 2.99. This is what you're looking for, okay? In this step, these are going to end up being subscripts on a formula. These are going to end up being subscripts on a formula. So, I have to look for, the last part is multiply to whole, right? You're looking for basically, like, this middle one comes up to be 2.99. Go ahead and round up to 3. So you're looking for stuff that ends in 0.25, 0.33, 0.5, 0.75, like nice fraction numbers that you learned in 4th grade. That's what you're trying to round to right here. So when it has 2.99, I'm going to go ahead and round to 3. Do not round any time before, but when you get to this part where you're at the end of step 3, go ahead and look for like 0.33, 0.25, 0.5. Those fractions that are like, you know in your head. You know what I'm talking about? You'll see it with practice. So anyway, I'm going to go ahead and write down 3 moles right here. 3 moles of hydrogen. My pen is going crazy. 4.05 divided by 2.7. Alright, see how that's 1.5? That works. Yeah, I'm trying to make this be as pretty as I can. It's not working. It's like getting all crazy with me. Okay, percent to mass, mass to mole, divide by small, multiply to whole. Can I have, okay, this is where I'm going, y'all. Look, I'm trying to get a formula with C and H and O. So I could write down 1.5 right here on the C. That's the moles of carbon in this formula. 1.5, 3, and 1. But can I do that? This is just like with combustion. What do we have to do? Multiply by 2. So, multiply to a whole, I'm about to multiply all of these by 2. This one by 2, that one by 2, that one by 2. So, this is going to be 3. This is the formula. This is empirical formula. We just did a formula. That's what we're doing. We're writing a formula. We're not done until we write the formula. This is a 6. That's a 2. You're done. See how that little poem helps you? You're welcome. Alright, I want you to try one, okay? So the one I'd like you to try, you can just do this straight in your notes. These problems take a long time, so I didn't even print a worksheet. But you can go to page... I found it. Did I close my book? Did you see how I was pleased with myself when I closed the book? Yeah, that happened. It could be worse. It could be worse. Okay, maybe it's not worse. But. Empirical formulas. Alright, you're going to do, please, and thank you. Do number, oh, that's fun. Do number 58 on 346. Can I make this go away? I'll write that down if you do. Got it? Alright. I'll scroll down. Page 346. Number 58. Give that one a whirl. I want you to try first. It only has 2 elements, so it doesn't take as long. Stoichiometry is, okay, at this point in our lives, we have not done any chemical reactions with these moles, okay? So when we get this mole thing down with one substance, we're going to apply it to chemical reactions. I'm glad you came in when you did. Did you catch some of that? You only missed percent composition, which is like a part about the whole. So if I ask you the percent composition of aluminum oxide, you have to have aluminum oxygen, and you would take the part that's aluminum times. So you Y'all, please do it like I showed you, stacking them on top and carrying it all the way over. It's just a lot neater. It comes out better. You forgot, that's how you start. Dividing by whole part. So the divide, so you're not there yet. Don't round until you get to the divide by whole part. That's where you're starting to look for those fractions that you're familiar with. Has everybody at least got this far, converting to moles? Are you saying the poem to yourself over and over again? Hopefully. Percent to mass, mass to mole, divide by small, multiply to whole. I'm going to make you write it tomorrow for the new now. Did somebody say why? Okay. I don't know if you saw my face when I turned around. I'll do it again if you want. Oh, that's right, yeah. I even like to give myself 3 decimal places right here. Personal preference. It just makes it easier when you get to the next step. Have you all gotten to the dividing by the small one? Okay. Oops. That actually doesn't have a unit. My bad. So, is everybody sitting at 1.5 and 1? Now listen, I know they both have come out to be 1.5, but sometimes this might be 1.33. Can we just pretend like it's one? Like, don't write this down, but can we just pretend for a second this came out to be 1.333? Can we do that? What would I have to multiply by? And then my formula would be be 4 oxygens and 3 nitrogens. Okay, like that's not the case, but if it was, or if it was 0.25, you know, I'd have to multiply both of them by 4. Okay, just making sure. So that was 1.5, right? Okay, so I am going to multiply both by 2. Don't stress, like don't lose sleep about this because it's a multiple choice thing, but when you write formulas, as a general rule, the least electronegative goes first, so it goes left to right on the periodic table, so it should go in 2, because I'm multiplying both of them by 2. Do y'all understand why I multiply both by 2? Yes?
When it comes to rounding, would you round to the 0.33?
Yeah, so if you saw on your calculator 0.328 or something, you would know it's really a third.
Okay, so the difference between 0.33 and then just like 1. If it was like 1.33 and...
So really you're looking for a quarter, a third, or half, basically. Sometimes you'll get 0.75 and stuff, and then you have to multiply that by 2, but that's more like AP kind of stuff. Alright, so go ahead and do number 59 on your own, and then we'll call it good. I forgot to take your homework, didn't I? Did you have homework? What's the matter? What are y'all playing? Is it? Oh, this is the wrong class. Okay, pack up. We'll do more tomorrow. Don't do any homework. I was thinking about how next period ends at 47.